Make no mistakes about it, the race to humanoid bot supremacy is now in full gear. CEO of NVIDIA Jensen Huang, fresh off last month's conference where he showed off their partnership with 9 humanoid bot companies, is now on video talking about how he sees in the near future manufacturing costs for humanoid robots to be much less than you'd expect, and likely between $10,000 to $20,000. Today, we're going to watch that video. We'll also hear what Elon said about the cost of bots, and also a recent post from Brett Adcock of Figure AI about what are the parts that make up a humanoid bot. We got Dr. Scott Walter joining us. Now, this guy knows a lot about this because he has run 2 industrial robot companies in the past. He's been studying like a hawk every single part that goes into these bots. We're going to walk you through each of these bots and how they're made. Thank you so much, Scott, for joining me.
Yeah, thanks for being here, Herbert. And boy, I wonder if Jensen was talking to a couple of the CEOs around there to get an idea of how much these things put together. Because do you think he just pulled that number out of the air?
Exactly. He would know. He's partnered with 9 human robots. Mm-hmm. So he's obviously diving deep into this. And rightly so. It's a big, giant market.
And does he know anything about manufacturing?
Well, he knows how to create.
Yeah, about building stuff and the costs and volume driving costs down. Any experience
scale.
in that?
He has skills in that, yeah. Interesting. Good point. Okay, so let's watch him talk about this. Thank you for Sarah Sutra for pointing out this and getting me that clip. He says in the near future, human bots will be available for $10,000 to $20,000. Let's listen in.
New category of devices for all of us to be building in the near future are going to be humanoid robots, and you could just see that the manufacturing cost of a humanoid robot is likely to be a lot lower than people would expect. Why would it be any more than $10,000 to $20,000? And you buy cars for $10,000 to $20,000. Why can't you have a humanoid robot for $10,000 to $20,000? And that robot will likely be a lot more agile and more versatile in an environment, in a world that we designed for humans. Mm-hmm. And so manufacturing lines were designed for humans, warehouses were designed for humans, a whole bunch of things were designed for humans, and therefore it's more likely that a human or robot would be productive in that environment.
So that's his opinion, which is great, listening directly from Jensen Huang. And Elon himself replied to that video saying that is true. Later, we're going to walk through exactly what Elon says about the difference between building a car and building humanoid bots. So before we get there, what's your reaction to what Jensen said?
Well, that's sort of a similar line of thought that a lot of us have had, not just myself, but James Dama and others, that you kind of look at it and say, well, if you look at how much it costs to be able to produce a car, which is far more complex, it seems reasonable you should be able to just kind of based on that principle. But of course, you have to get the numbers to get there. And I guess one question I'd ask you, Herbert, what do you think is one of the most complex pieces of equipment that are actually going into these humanoid bots, the most sophisticated one?
Well, you told me already. You've told me many times. It's the actuators, right? Can you explain?
Well, the actuators are going to be tricky. They might be the more costly, but from the standpoint of technology, it's chips, isn't it?
Right.
You think about it. The chips that's in some ways the hardest thing to produce. Mm-hmm. But we know how to do it. We know how to do it pretty cheap. And Jensen definitely knows how to do it pretty cheap. He knows what goes into building these big fabs and the lead time and all that stuff. He knows how complex that is. So it's not like you can pull the wool over his eye and just say, it's like the price of a Model 3, can't be more than that. Now he's doing a more rational, deeper analysis. Yes, he's hearing it from everyone else. But the reason he's hearing from everyone else is sort of doing the same things. Now, most of the CEOs, let's say, have been very cautious. They don't really want to give a number like 10,000 right now because they want to make sure that they kind of sandbag it a little bit and not get expectations up too high because they don't know what the hurdles are. And again, we said it's the actuators, and that's what's going to add up to be most of the costs. And we've seen Brett, is going to end up showing a similar kind of breakdown that we've talked about before. It's like, well, what actually goes in there? When you actually look at all the various components and everything start adding up, you begin to realize it's where the actuators are and figuring out how to bring that down. But we know how to make motors. We know how to make electric motors, make them all the time. We know how to make them scale. We know how to make them at a cost. Actuators, they're fancy electric motors. Okay. So they've got a little bit more to them than just that. And they're a little bit more bespoke than these large volume ones, but there's still no reason why you can't bring it down in cost. And again, we are looking at some pretty sophisticated motors that go into EVs. And with gear trains and everything else in there, far more power density and everything else. And those are able to be produced for about $1,000 already. And so if you kind of take that and say, yeah, well, they're scaled down a little bit, worst case, they're $1,000 a piece. I got 40 actuators, I'm talking about 40,000 in actuators. The rest of the cost is incidental. Cameras are that much, you know, the CPUs you're going to have in there, the battery packs, you add that up, you'd be really hard pressed to come up with another 10 grand. So you can get the 50, okay? Easily say you can go under 50. And that's what Brett's talked about in the past. He brought that number up, and a few of the others that wanted to be like, well, yeah, we know we can get under 10,000, but we don't want to tell everyone we can get under 100,000. Sorry. We don't want to tell everyone that we can get down to 10,000. We want, you know, it's going to take a little while to get down there. So it's a completely reasonable number. You know, Jensen was saying between 10 and 20, you should be able to do it. We've heard that before, and I've seen nothing about those statements that would tell me that, there's no way. Because right now, these bots are $250,000 a piece. It's like, you're right. And so is like the first test mule for any car that someone is putting together. That's like $500,000 to $1 million. So do you jump to the conclusion, my goodness, that test vehicle is like $1 million. It's going to cost us $1 million to build. It's like, no, when you start to scale up, you can start bringing that cost down.
Yeah, these are costs once it's at scale. So you talked about Brett Adcock. Let's take a look what he said. So Brett, you know, he said this very recently. He said, if you break down the bill of materials for a human or robot, you're left with a straightforward breakdown, right? Structures, that's the kind of the covering for the bot. Motors, that's the actuators that you're talking about. And the reason why that's expensive, and we'll walk folks through later, what the actuator is, what the motor is, how many are in a bot. But you know, if there's 40 of them and they're $1,000, then that's automatically $40,000. And that's why that needs to go down. But you said battery cells, PCBs, right? CPUs and GPUs. So that's the computer systems here and the cameras. And that's what you're saying that, you know, these things are like, yeah, this is like a, these are expensive, but they're already out there. The only thing that's brand new is really the the motors. And so let's take a look at, I'm going to pause this again, but we're just having a look at the Figure robots. Now, Figure's robot does look like that it's not yet Gen 2, right? It's going to be cleaned up. You see cables out there. It looks a lot more bulkier than, let's say, we'll show you the videos of Optimus. And then look at that giant backpack. They've not yet optimized for the batteries yet. They'll be doing that soon. They're here just showing you the intelligence. This bot can be shown autonomy. It can now be taught how to use a Keurig in this case, and it's able to do that. And that's why it's important to have fingers, by the way. You can use a normal Keurig and it knows how to press the buttons, knows how to, manipulate it. And that's really key. That's why they did this. But tell me more about just by what Brett said about the cost, the parts of the cost of a bot.
Okay, so if you look at the structure, it's made out of metallic materials, which is generally aluminum. The bill of materials for the aluminum will be at most a couple $100. I mean, and to get aluminum castings doesn't really change the cost by that much. So whatever you would need for the structures is not going to be that much when you start to get to scale. At first, it's costing them a little bit because they're doing CNC machining for a lot of it, as opposed to just doing castings. But when you do to the scale, you're talking about like, for whatever the structure would be in an upper arm or lower arm or something like that, being like $5 or $10 at most. It's not a much. So the structures, you can almost say
they didn't have much to show.
Not going to, it's not going to be that much for the structure. So when you see, what's along the arms, some of the, a lot of the breastplating and everything else you see, that's probably going to be plastic at some point, some sort of injection molded plastic. That'll be really cheap. The cameras, well, we get cameras in our pockets that we're running around, and they're all really pretty good. And, the camera in here cost me, I don't know, maybe $700-800, but it came with a phone and a screen and a bunch of other things in there. And so just a little bit that's in there, that doesn't cost very much. So they got a bunch of those things. So forget about the cost of the camera, the steps and nothing. But oh my God, there's batteries, that battery pack. That must be pretty expensive. Everyone tells me my Tesla, that's the most expensive part of the battery pack. It doesn't have a full Model Y's worth of batteries in there. I can go out and I can order that battery pack, the number of batteries you need to go in there from Amazon, and it would cost me $800 delivered to my doorstep. They can get them for easily half that price. So you're talking about $300-400 in the batteries. Okay. So you kind of go through that whole list and everything that's on there, and we're getting hard pressed to already get a couple $1,000s worth because, okay, you get the CPU, you're going to have one of these fancy NVIDIA GPUs. That's probably going to cost you $1,000 or something like that. And some of the other PCBs that you're going to need for other aspects of it. But again, they add up as small amounts. And, if you get $6,000 in material costs at that point, okay, what's left over? It's those motors. Remember, you're talking about the motors, the actuators. And what's the cost of that? If you have 40 of them and you can build them for $100, that's like $4,000 right there.
$4,000.
Oh, 4,000. It's like, we still can't get past the $10,000. Okay, double it. So maybe it's $200. Okay, now we're talking about having to add $8,000 on. But it's only when you get up. So I'm pretty confident they can build those actuators for $500 in like the worst case. And so you're talking about maybe, because there's about 6, and again, that's saying like 40 actuators overall, and that's including what's going to be like a dozen for the hands. So you're talking about 28 of the big boys, and then the smaller ones there, which probably won't be as costly. How do you get north of $30,000-$40,000? I don't know.
So we'll dive deeper.
And you
into
do
that,
it by only selling a few. That's how you get north of it.
But Elon said complexity per unit mass is much higher. And so that's where it still is going to be a lot more complicated. Let's do a deeper dive, and we'll show videos of how Tesla builds their bots and what they're able to do, because they're the ones that actually drop those videos a little bit more. So here's Sam Korus of ARK Invest. They've done deep dive research on bot. They're about to release their bot model. Sam says this: a human or robot is less than 1/10 the weight of a car. Can the manufacturing ramp be 10 times that of a vehicle? So this is, he posted this a month ago, and then Elon replied to him, right? So he's saying, hey, it costs a lot less than 1/10 of a car. Does that even matter? Seems like the constraint is going to be a software capability, not manufacturing capability. So this is, again, some people are still thinking that software is the constraint, when in fact, people are actually now saying the opposite. So it's 10 times less parts in a car, 20 times less mass. I think you figured out it was 30 times less mass, right? The mass of a car.
Yeah, I mean, it's something like that. So the battery pack, for sure, it's only about a 30th of the size. And yeah, it's probably also about that scale. So it's more than 10 times or less mass, for sure.
He said there's no limiting factor getting costs to $20,000 with enough manufacturing volumes. The engineering difficulty will be getting the robot reliability high enough to induce enough demand for millions of units, challenging but doable. So Elon replied to him, says complexity per unit mass is much higher with human or robots. But still, I think it ends up costing less than half of a car.
Right.
Then Kristen said, so you're saying 25 to 30,000 costs for a humanoid robot, which is very on the high end of a car.
Kristen, she drives a high-end car. That's fine.
He says less over time. And so I'm going to play some videos, and while they are, why don't you tell me a little bit more about, just to remind folks, this is what the humanoid.
Yeah. So to remember, when you talk about like complexity per unit mass, if you look at like a bumper or a trunk or something like that, it's very massive, but not very complex, right? When you start looking at the bot, just about everything is complex, because most of it's the motors, and the motors are not just lumps of metal, but there's a lot more complexity. So I agree. If you look at it like per unit volume, per mass, there's a lot more going on there in that particular area. But you also got to remember, Elon has this thing called an idiot index. And that is that in some ways, the cost of something should be directly proportional to the amount of material you have in there. And if it ends up, what the raw material cost is. So if the raw material cost is $200 in aluminum, the darn thing shouldn't cost $200,000 to build, because it's just like, that's his idiot index. It's just way too much for that. It should be a smaller amount. So even using his own kind of principle, that you would sort of say that, yeah, the cost should be less than a car. It just makes sense. It's a question of how much less than a car. Is it like just 5% less than a car, or is it 50% less than a car? Where is it going to be? And part of it, again, comes down to complexity. But then again, I argue that, this thing here is also way more complex than a car. And it's only like $1,000. But if you put 30 of these things together, they take up also a very small volume. So that's part of it, is that, yeah, there's a certain amount of complexity that goes into something that's small of a particular unit, which is why there'll be the cost there. But at the same time, this is affordable. We're able to buy something like that. So we're seeing here how they're able to make these actuators already in the lab that they have. So they don't have a production line for doing it, but they do have everything that's needed to do it. It's just a little bit tedious because it's all very manual at this point. But at some point you can scale up those production processes to make them a lot faster. And that's what they've already looked at from the beginning. So the robot is very manufacturable because they want to make sure it's easy to put together. And part of it is to make sure that the components can be built at scale and at cost. And when you have those components, they can be assembled together very easily without very difficult assembly tasks. And they kind of drove home that point a little over a year ago when they showed a video of the bots putting another bot together. Now, whether that means they're actually going to be using the Optimi to build Optimi in the early days of production line, that's a little bit hard to tell. But what they're saying is that, look, it's so easy that even our bots, before they can really have all the dexterity and capability that we expect them to have, are already able to do things that are close enough to be able to show the assembly, because the assembly is so easy. So once you have that arm comes over and it pops in a matter of seconds. You just go in with some standard bolts, just tie it on down, put a plug in, and boom, you're done. So again, it's showing that they are designing for manufacture because they want to keep it simple. And this is Gen 1, which is, I would say, very complex in many ways. And Gen 2, as we can see, looks a lot nicer, a lot more refined, looks like it really is something that's designed to be scaled up. There was one other point that Sam also brought up, and he talked about not just the cost, but the ramp. That, you know, it's not as big, it's not as bulky. So it seems like you should be able to ramp this a little bit easier, right? Because you don't have a paint shop like you have in an automotive plant. You don't have these very large presses, all these other things. And I'd argue he's right. I mean, it should also be easier to scale this up. You're not going to have the same production hell. Not that you won't have a production hell, not you won't have this, but it seems like you would be able to get through that a lot quicker and get fairly high volumes fairly quickly. So when they're ready to produce these things, they'll be able to produce them in pretty good volume pretty quick compared to what we were used to when we were looking at like the Model 3 and the Model Y ramps. And definitely will go faster than the Cybertruck ramp. I'm pretty sure of that.
Right. So let's get back to this bot making bots, because you've told me before that actually the way Tesla will do this, and just by looking at their bot here, right, it's so clean and crisp. You might not, that video that they showed about the bot making a bot, that was just for show. Like, you may not need to do that, right? And they were just trying to show you that, A, it's cool, B, that the bot can use tools, but they won't be doing this. They won't be using a drill, right? Because it's going to be like mass produced. It's going to be factories. It's going to be like, all automated with industrial robots.
Yes. A lot of the piece of equipment are going to be coming out of specialized machines that just able to produce them at high volume and low cost. So, plastic injection molding, those things that just be getting popped out would be one example. You'll probably have casting machines that are making the upper leg, lower leg, those different sections. Some of them maybe have to then go into a CNC machine. So you may have some loading and unloading of those things, which typically are done manually in some cases. So maybe that's where you have a bot going in there that'd be doing some of the loading and unloading tasks on that. And then whatever line they had to make the actuators, I think it's going to look a lot like, the battery line that we keep on seeing, the 4680s. It's going to be highly automated, and like everything kind of goes through. And in the end, you start producing these actuators with very little manual steps necessary in there, if any at all. But at some point, those actuators have to come together to start forming structures like the arms and the legs and the torso and everything else that goes in there. And that's typically where you have some sort of assembly process where you need some sort of dexterous piece of equipment, usually a human being, to go ahead and do it. And that's where the bots might come in to do that sort of final assembly business there, which is why we were seeing that earlier. So what we're seeing right there, that's very manual. That's because they're building the very first ones. That's something that will be automated eventually. All that just come right out of the machine. And the analogy I like to use is that you could use bots or humans to bottle soda, right? You could have a line of bottles, and then someone just takes it up and goes over, fills it up, and puts the screw cap on there and does that. And we can do that, right? And we can even make the bot do that. But it makes more sense because the volumes we want to come up with hard automation that just does the bottling like really, really quick. And so you go to any Coca-Cola plant and see what's going on. It's like, phew, it's like everything is designed that way. So there are places where hard automation absolutely makes sense. So like pumping out the actuators and stuff like that, you're going to be doing that. But then there may be some where it comes down to like, okay, where is sort of the manual process? In some cases, stuff that's coming off the line, Maybe the bottles get put in to the boxes automatically. In the old days, they weren't. People were still doing that. But at some point, the boxes, maybe they get stacked onto the pallet. At some point, humans are going to be touching the process. You can automate up to some point, and then something else will kind of come in there. And I see the same thing going on with the production for the bots. Yeah. The cost will go down, partly because the bots will help drive the cost down, but the part complexity is not that high. Like I say, what I think is the most high-tech piece of equipment that's in those bots is something that I could not build in my basement. I mean, basically, everything that goes into Optimus, you and I could probably build in our basement if we just get the right equipment and had enough knowledge. We could build these little motors. We can do stuff like that. But those chips, you need a chip fab for those things. I'm sorry. It's like, that's really sophisticated. But the irony is like, is like they're all over the place and they're producing such a high volume that you can get them really, really cheap. So while it's the piece, without that, you have nothing, right? Without the chips, you really can't do very much, yet they are affordable. And Jensen already knows how to build those things, right? So, and he knows how to do them at scale. So he knows, the hardest part of the bot, we can do it at low cost. So why can't you do the rest of it?
Yeah. I bet you people don't realize this, but you can buy a bot today. You can buy a bot today. So you and I interviewed CEO of Fourier, Chinese-based company, Singapore-based company. And you can go to the website, and I just did, and you told me to do this, and it says here.
Yeah, well, this is Unitree. So Fourier, you can also buy it, but this is the Unitree website. Is Unitree.
Yeah. Gotcha,
right. So Fourier, you can. I'm not sure if it's on their website, but Unitree, you can. So that's one. And there it is. Yeah, you finally found it. $150,000. So basically, you can order it, and that's well above their manufacturing costs. Right now, they're able to sell it for that much because supply and demand.
Supply and demand, but also that A, like you said, they're not scaling this quite yet, and B, it's not yet like there's software integration. You need their teams to help integrate it to get it going. It's just like all that manual work still. But what we just covered today is the three CEOs of NVIDIA, Brett Adcock, and you've got Tesla Bob saying that it's going to cost a lot less than people realize. You've been saying this for a long time. People didn't believe you, but we're going to get to the $10,000 to $20,000.
And I didn't believe myself at first. At first I was thinking about it, and it came from when I think Randy Kirk was the first one to ask me, and I was like, boy, I hadn't really thought about that. And I went through this bracketing exercise of like, well, it should be less than a Model 3. And it should be more whatever the material costs are. And then I look, it's like, what are the raw materials? Like, well, if it's titanium, we're talking $8,000 for the amount of titanium you'd make. But it's not being made out of titanium because they told us they're not going to use titanium and they're not going to use any exotic materials. So it's mainly going to be aluminum, not even carbon composites. They would use plastic injections. Just like, well, that doesn't cost a whole lot. So I finally did the bill of materials, just like what Brett did, came through it. And I had a really hard time getting myself above 10,000. And I had to keep on coming with this, and I realized that the real key are the actuators. That if you can build the actuators for next to nothing, and you can buy motors on Amazon for like, $50 to $100 easily. Some of them are pretty sophisticated as well. Not quite the same as that, but I just have a feeling they can scale it and get it down to that price if they want. So in the end, I realized that, you really can do it for less. And it took a while to convince myself.
It's only now that actuators are able to be priced at this level because they're specialized, because they need to, they need to carry heavy loads, right? We show that Tesla Bot is able to carry a piano, and then the constant use of it, right? And it's got to be designed a certain way. This isn't just this is something that's going to be moving all the time. I wanted to get your feedback on this because we just interviewed the CEO. The CEO of 1X, Brent Bornick, and they've created this bot called Eve. Now, Eve is wheeled at this point, but they're creating a Neo version, which is humanoid. When you first look at this bot, you're going, oh my God, compared to Figure, compared to Tesla Bot, compared to the others, this looks like a toy. But there's a very specific reasons why they're doing this. They're the only company that has announced that they're going after the home market, going after consumers. And so they needed to make the bot less than, 60 pounds? Do you remember?
I think 66 pounds, 30 kilograms.
And they talked about, they don't want to tell you the full things. He was careful, but it's like, I don't think they're using the actuators. They're using tendons.
They're using a different way of actuating.
He called them tendons because he said that it needs to be, if it's at the home, it's got to be something that if you fall, if it touches you, it's not going to hurt anybody. And that's why they did this. And that's why it's designed this way. And so now you realize, oh my God, there was method to this madness all along. They're the only ones going after the home first. So their cost, Scott, could be even lower than the 10 to 20. And they need to be if they're selling to consumers.
Yes. And that's what he's been on the record for saying that yeah, easily, I think, was it around $10,000? He said. It's like, so for him, he thinks, yeah, absolutely 10,000. And partly because it's been simplified enough, and he's reduced the mass. So in some ways, if he's really able to get the mass down to 66 pounds, like, man, this is not a whole lot left there. There can't be anything to, where's the cost then? So they're coming up with some novel way of being able to do the actuation, which is clearly helping them to reduce the cost. And he knows how much it's going to cost him. He said they already have all the equipment to build everything internally. And he is definitely convinced they can do it.
Yep. They're going after the mass market next year. 1,000. They're in beta already. He disclosed to me. So if you guys want to watch that video, it's on my channel. They're already looking for a beta program. He has an Eve at home, a Neo at home, which has the humanoid legs and feet walking. He's got that.
And fully formed hands. So what you're seeing here is their previous generation. They've made a little bit of an announcement on what the Neo bot is going to be. They've shown some stills of it, but they haven't really done a full public unveil yet. And that's going to be remarkable to see, especially if they can do it at that cost point. Because when they do that, then okay, it can be done.
So Scott, this is the thing I think, why are we spending the time talking about how it's going to cost less than 10 to 20? You've had 3 CEOs talking about this. We've interviewed quite a number of them, including Bernd Bornick. The AI part, the training autonomy, is they surprised them all how quickly you can now train them to do autonomous work. That's really was the key thing. The cost of the actuators is the thing that was limiting them. And now they're telling you that I think we can get this to 10 to 20. And so, at the end of the day, is there any blocking rate limiting step at this point, except for scaling and manufacturing? This is happening. It's going to be rolled out. Yeah.
It's just having the AI complete, and having something that is able to have all the functionality that you need, that you would be comfortable putting in a home environment, just the final packaging and everything else. And we could just assume that can be taken care of because companies do that all the time. And when the first iPhone came out, it wasn't ready. It was a demo product. It was still another 6 months before it was ready to be packaged and have everything that you normally need to have in there. So once we see that there's some bots doing some amazing tasks very easily, and that they've gone through their second generation, you can see it's streamlined already, then it's just cranking it up. And then you'll see the prices come. The prices will be high at first because they can charge that much, it's not because it necessarily costs that much, but because the demand will be so high, they will be able to do that for a while, but it does not mean it's going to be costing them $100,000 a piece to build. Absolutely not. Absolutely not. So I'm pretty sure the cogs and everything else that would go in there, they will be pretty low almost pretty quickly, even before you do a full ramp up.
Yeah, so we've seen prototypes, and Elon has said many times prototype is easy. In this case, it may not have been that easy, but it is certainly easier than manufacturing and scale. Then so far, none of these other robot companies, except for Tesla, can show that they can do this. That's the next thing we're waiting for, is manufacturing at scale, showing us, partnerships, right? We had Sanctuary announce that they have a partnership with Magna, who's an automotive supplier, has factories around the world. They create all big and small parts. And so they've stepped up and says, we'll make your bots for you. We've had Digit say that they're going to create their own factory. So we don't know where that is, but Portland, Oregon, 10,000 bots per year. They're going to get started on that. And then so far, we haven't heard of anybody else at this point. Yeah,
we know that Foya is building some stuff. So they're building a reasonable number of them and as well as Unitree. Unitree's already been building their robot dog in fairly large numbers. So they already know how to scale that, probably using similar technology and actuators in there. So, you could see them. And the fact that they're already selling them means they're able to produce them at a reasonable scale. And I think all of them are saying that, this year in the order of like 100 or something like that. And they all talk about being able to 10x every year after that. So next year, about 1,000 and then 10,000 the year after. And then by the time 2030 comes around, they're all producing 1 million a year.
Million each.
And that's when you notice. And I think it was Dr. Jim Fund that said that, what it's going to be gradual, then suddenly. So there is that little buildup up there, and we're not going to see them because they're going to be bought by all the businesses. Because that's why I say they'll be able to charge a lot of money, because these things will be money makers for a lot of companies. So businesses will absorb it. We won't see it, but it will be touching a lot of the products that we are using every day. We're just not realizing it. And then at some point, the businesses will be saturated. And then where's the next market? The home market. And then suddenly they're there. And it was the same thing with the smartphone. I mean, it was gradual, then it was suddenly. And then suddenly everyone had one. And like you were looking around, it's like, oh, I'm the only one without a smartphone. Why is that?
Yeah. And then I think we've done other deep dives on the business model. And in some people, they estimate that if you have 1 million bots, if you're just making 1 million bots a year, you're already a $10 trillion company.
Yeah. Yeah. And now,
like,
do you think you're going to buy a bot when it becomes available?
Can I buy a bot when it comes available?
Well, when it's available, would you?
Of course I would. I mean, I would.
Yeah.
But
I'm just thinking of the average person. I mean, I'm thinking about this situation of like being at the airport one day and it's waiting to get on a flight that's been delayed, and suddenly they announce it's canceled. And the guy behind me is like on his smartphone, get the next ticket for the next flight. And you get your flip phone, looking around, which counter do I have to go running to? And that's when you realize that's like, yeah, I want that. And it's going to be the same thing with the personal robot. When you begin to see people around you, what they're able to do with it, you're going to realize, hey, yeah, maybe it is something I want to have. Maybe it would be pretty useful, especially when it goes and, does the landscaping for you, picks up the grocery. Does all sorts of things. If
it turns out to be like a Roomba, which is, poor, it doesn't really do a great job, but it still became pretty.
It's good. It'll do a better job than Roomba, guaranteed.
If it can do a better job than Roomba, it can actually do a number of useful tasks. There's no doubt at that point. It's going to be
in some ways, the Roomba might be the reason people hesitate, because today there was like a bunch of threads out there of people just have had it with their Roomba, and I wasn't surprised to see it because I got one and I kind of had it working, and then I tried using it the other day and it was just malfunctioning, doing weird stuff. And it's like, wait a minute, I thought this thing used to work and it doesn't work. And then it's going around. It's like, it's a bulldozer pushing the dirt around. It's supposed to be self-emptying. I checked everything. It's like the dust bag is empty. It's like, what's going on? Why isn't the suction working? And the wheels were going around on the carpeting and making lint balls all over the place. And then it wasn't vacuuming them up. I had to go and clean them up. And so, the Roomba is giving people a bad taste about these home automation. So they're going to have a lot cut out for them to be able to convince people that it really will work in the household without like knocking everything over and scaring the cat. Yeah.
Lots of work to do still. Thank you so much, Scott. That was good. This
You're
is
welcome,
important to know the cost of how to build these bots. And everybody's saying it's a lot less than we think, because if it is, then I think the progress is going to be faster than we all think as well. The scaling of it, they're going to be rushing to scale it, because the more they scale, the lower the cost. And then the bigger the economic returns for them. So it makes sense. Okay. Thank you so much, Scott. Appreciate it. Follow Scott on X at GoingBallistic5. Check him out there. Thanks, everybody. Bye-bye.
Yeah. Thank you, Herbert.
I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.